Here's a bit of a funky looking problem with a graphing of a rational equation. Start by factoring, and what's going to happen is your whole numerator is going to go away. Your bottom you had to factor by grouping, and we're left with 1 over x minus 3 squared. So before we even go into anything here, take a look at the fact our numerator has a less degree than a denominator. That means that we're going to have a bigger on bottom scenario, so we're going to have a horizontal asymptote of y equals 0, and that's pretty evident to see in this factored form. We can't do long division. It's like we already have. We have a good remainder that is less than what we have in our denominator. So y equals 0 is our horizontal asymptote right off the bat. Our domain, the denominator equaling 0, is negative infinity to negative 3 to positive 3, and from 3 to infinity. X-intercept and y-intercept, again, be careful. X-intercept is when the numerator equals 0, but make sure you use that factored form because those guys canceled out. So we actually don't have an x-intercept here. Our y-intercept, if we use the original equation, I get 3 over 27, so I get 1 over 9. So a really, really small y-intercept. Vertical asymptote, interesting scenario here because we actually have it twice in the denominator, but it's the same either way, a vertical asymptote at y equals 3. So I know I'm going to have a vertical asymptote right there. Whole, we said is when we canceled, so x equaling negative 3. I need to find a y value for that, so I do that by plugging negative 3 in here, and you get, negative 6 for both, so you actually get like 1 over 36, so a really, really small value there as well. And finally, for crossing, we won't cross because our remainder has to equal 0, and it never will. So there's our asymptotes, and now we can plot any of the points that we know, which we said we had a y-intercept at 0, 1/9, and a whole really, really close as well at negative 3, negative 1 over 36. So the only thing we can do to connect those dots is to basically go right along that horizontal asymptote and then start to eventually make our way up after we connect the dots. As for the right hand side, because we already got the first two parts of the domain, just like we've done before, if we go to the right here, plugging in, for example, 4, I would use into this part of the equation. I would plug in 4, and I get positive on top and bottom, so that means I'm going to have something that's up above the axis. And this is kind of cool. We haven't had many of these where you're going up and then immediately coming on the same exact side. A lot of times we've had this kind of alternating, going across a quote-unquote coordinate plane of the asymptotes like we've been doing before. That doesn't exist in this case, and the reason being is because of this squared. That function has to always be positive, so when you started positive, you're going to come on the exact same side from the other way. Again, a big idea when you get into the idea of limits and calculus right there. But when you see that squared, very possible and actually guaranteed that you're going to go up and down on the exact same side of your asymptote.